All right, welcome everyone. Hello. Go ahead and begin class. Hope you all had a great weekend, as I'm sure you've probably seen, or maybe you haven't seen. I don't know if you've checked your inbox lately, but the exam grades are out. So we got them all finished up grading yesterday. I'm not going to talk a whole lot about the exam right now, other than to say that it went well, from my perspective at least. It went, grades were what they usually are on the first exam, so no huge surprises there from what I saw. The regrade requests are open. So all regrade requests have to be submitted through GradeScope. If you ask about a regrade request on Piazza, we're not going to deal with it there. So please submit all your regrade requests through GradeScope. You're welcome to talk to the TAs about the exam if you want to. If you want to work through a problem or something like that. They cannot regrade your exam for you. I am the person who does the regrades. So if you think a problem was graded incorrectly, submit that regrade request. You have a week to go over it and get those submitted, and then I'll take a look at them, get them all taken care of sometime next week. I think that's really about it that I have as far as announcements go. I'm actually just anxious to keep chugging along with the course material. We got 3 more weeks until spring break, so we're going to cover an interesting topic today. You can see the title of this is called Input and Output. And we've actually already been, let me take a step back. I'm going to go through the exercises for today. I saw some people asking about this on Piazza and other places. If you want to grab, so the course is broken up into 3 chunks based on when the exams are, right? We just finished exam 1. We're about to begin the next section of 3 units, so over the next 3 weeks. So the exercises that I'm about to go through today are in a different repository. The link can be found on the Module 4 exercises page on Canvas. So if you want to grab the exercises for not just today, but also next week and the week after, be sure to track down that link on Canvas, grab that repository. Okay, I'm going to go ahead. I've actually already got it loaded up. I loaded it up before class, so I'm going to go ahead and get started by talking about something that we actually have already discussed quite a bit in this class, which is the scanner class. So we've used Scanner before. Scanner actually is an example of what I would call an API, which stands for Application Programming Interface. What do I mean by that? Well, Scanner's doing some work for us. Scanner's been doing some work for us. How does it actually do that work? When I say, int x equals in.next int, something's happening there, right? Like that's work that's being performed for us by the scanner. Do we need to know how that works? Not really. We need to know that it's going to give us back an integer that somebody types into the keyboard. But how does the computer actually do all that stuff? I don't want to get into that. In fact, I'm not even sure that I really know. Like, I could probably go figure it out if I really wanted to. But all I care about is, the user pushes 7 and hits enter, and then I get the 7 in my code. All the stuff that has to happen to make that work, that doesn't really matter to me. So by using an application programming interface, by using an API, it allows us to take code that already exists, right, and use it within our own code to develop our own solutions without even necessarily having to know or understand how that code works. It's actually a very, very, very common thing in computer science. We basically had you doing this since day 1. But the goal of today is to get you to understand that actually there's information about this stuff out there. So yes, we've told you some things about how the scanner class works. And maybe some of you have looked up some other information about how the scanner class works online, which I think is great. As programmers, I think it's important to understand that we are not going to be able to know everything. It's just not possible, right? There's so much stuff to know, and it's changing all the time. So we need to be able to look stuff up. We need to be able to reference important materials when we need to. So if I'm using Scanner in a project and I don't know how to use it properly or use it for what I want, I might come to my good friend Google and type Scanner Java. And one of the first things that's going to pop up, yes, there's lots of other sites with tutorials, and I recognize some of these things. But the one that I'm really most interested in is the one that includes Oracle in the name. Oracle is a tech company. They're the ones that actually make Java, right? So Oracle is the official Java source. And what this is the official documentation for the scanner class. Whenever you see a page like this is a very common page for me to look at as a Java programmer. And if you're doing things in a different language, then it wouldn't be on this website, but there would be a similar looking set of resources for you for that particular language somewhere else. But for Java, this is the official instructions on what the scanner class can do. And a lot of times they'll even give you some instructions on how to use it. So there's a quick little, we've seen code like this before, right? There's a quick little introduction to how to use the scanner class. Here's some more complicated examples that we maybe haven't seen before, but maybe they're relevant to us, maybe they're not. The real important stuff to get at is typically down here. So almost always on these pages, you're going to see a constructor summary, which doesn't really do us a whole lot of good right now. Once we get to objects, that's week 7, so we're still a little ways away from that. Then this will start to make a little bit more sense to us. But something that is going to make sense to us right now are these method summaries. And if I scroll down here long enough, you'll see that I reach some that you recognize, at least I hope you recognize. There's next byte, next int, right? Next line. We've seen these before. We've asked you to use these in class. And here's a little description that says, these descriptions, granted, might be a little hard to decipher. Scans the next token of the input as an int, but it's still more information than we had about it before. And you can actually click on these, and it'll give you even more information, which again, you do kind of have to decipher. Some of these words maybe we don't understand, maybe we don't fully get, but other things, maybe we will understand. And the trick is, we don't have to understand all that stuff, right? We're trying to solve a problem. The only thing that we really need to understand is what tools are necessary to solve that problem. So I just need to get enough information out of this documentation for me to solve the problem that I'm trying to solve. I don't have to understand every single case that's being presented here, every single word, right? If it's not important to me, I'm going to ignore it. And if I do think it's important to me, then okay, I'll spend a little extra time on it, trying to figure out what it's trying to say, see if it's something that I can use to solve my problem. So I'm going to show you some more things from here today that we haven't used yet before. And in the future, right, I'm not even going to tell you about certain things. I'm going to say, all right, you can do this. This is a thing that can be done on the computer. Go figure out how to do it. And the answer is going to be to look up documentation similar to this. Maybe it won't be for scanner. Maybe it'll be for something else. I'm going to show you similar documentation later on today for a totally different thing that's not scanner, right? But reading this and then deciding how to apply it to a situation, that's programming. That is what programming is. I do not sit down at the computer and bang out a working program from scratch, first go. That's not how it works. I write a little bit at a time, looking stuff up as I go to fill in the pieces that I don't know how to do. Because there's a lot of stuff that I don't know how to do. Maybe it's something that I've even already done before, right? But I just don't have the brain space to remember, because why would I if I can just go look it up? If I can just go refer to it again, right? I have other more important things to remember. So let's take a look at an example. We're going to stretch our use of scanner. We're going to switch over to Eclipse. I'm in the stats program here for the scanner class. Right off the bat, we're using scanner in a different way, and this is to kind of prep you for the upcoming homework assignment. One thing that we haven't shown you, but I'm going to show you right now, is that scanner can be used with files. So we've been using the scanner class to just take whatever the person types in on the keyboard, right? What if I want to read not what somebody types in on the keyboard, but what if I want to read information in from a file? The good news is that other than setting up the scanner a little bit differently, the scanner is going to work exactly the same way. So this code right here, you can see it's not your responsibility to understand this part, but it's actually also not that difficult for you to understand this part. These two lines here, you'll understand what these do in a second. They pop up a window for us to browse our files. They pop up a file browser for us to select a file that we wish to use for our program. This creates the file in Java, and then this line, which we have seen kind of similar to before, creates the scanner. The biggest difference being that instead of using system.in here, that's the keyboard. System.in is keyboard. We're using F. So we're saying don't read input from the keyboard, I want you to read input from the file. Again, this stuff will never be on a test. These lines never be on an exam. If you need them on a homework assignment, I will give them to you. They're on the next homework assignment. That's part of the reason why I wanted to go over them today, so you wouldn't be surprised when you saw it on the upcoming homework assignment. Let me show you what happens when I actually run this. Okay. All right, so this is what that code is doing for us. It pops up. You've probably seen windows like this plenty of times, right? A little file browser window. In it, there's two files. You can actually see where these files are over here, 1K doubles and data.txt. You can actually open them up and look at them, right? This is a file, as the name implies, that has 1,000 doubles in it. 1,000 of them. This one I don't think is that. Yeah, this one just has a few numbers in it, and they are not doubles. They're actually integers. But it's waiting on us to pick a file. I'll pick the big one with 1,000 doubles in it. And now it's time for me to scroll down and show you the second part of this program. There's a method that we haven't used yet from the scanner class called hasNextDouble. It's an important method, one that I think you're probably going to need coming up on the next couple of assignments. But let's figure out what it's actually doing for us. Let's refer to the documentation. This is a long page, right? This is a very long page. No way I'm going to read all this stuff. I've never written this page from top to bottom. It would put me to sleep before I even got a third of the way down, right? That's not what this is for. Be intelligent about it. Control F is your friend, right? Control F lets me find something within a page. I'm interested in has next double. Okay. Tells me this is an interesting word. We can, but again, do the best you can. Ignore the words that you don't quite understand and stick with the words that you do understand. True if the next token in the scanner's input can be interpreted as a double. But this is also important. The scanner does not advance past any input. So what this is telling us in perhaps more plain English terms is that it's looking at the next value in the file. If the next value in the file is a double, a number with a decimal point in it, it's going to say, yep, I see a double next. If it sees a string or a Boolean value, right, or something that's not a double, it's going to say, nope, right? So the answer that I get back from here is either true or false. Yes or no? There is a double coming up next. So if we go back to the code here, this while loop, remember, will keep running as long as things are true for the condition. So it's saying, while there are more numbers to be read in from the file, this is the code that actually reads in that number, and then we just print it out. If I scroll up and show you the output, you can see that when I ran this code, it actually did exactly that. It grabbed every single number from the file one at a time, grabbed it, and printed it out. Now, I want to show you that, I wanted to show you a couple of things, right? What happens if I try to do this twice per loop? What if I want to read two numbers in at a time? It doesn't seem like it should be that big of a problem, right? Doesn't seem like it should be that big. And maybe it won't be. I'm actually not 100% certain what's going to happen when I run this. Maybe it'll be a problem, maybe it won't. I'm going to try and play around with this until it becomes a problem, though. Let's see. Oops. Clicked the wrong thing. All right. No problems yet. All right, let's try it 3 times then. I'm going to keep pushing this until I get it to tell me that there's an issue. Ah, there we go. Finally got it to complain. I wanted to do this on purpose because this is a very, 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 very common mistake that I see students making on the upcoming assignment 4 and assignment 5 when they're using Scanner. Why did this happen? It might not seem like a big deal to read in 3 numbers per loop instead of just 1, right? That may not seem like that big of a deal. But think about what's happening here. It's telling us that when this is true, there is the next value in the file is a double. Just the very next one, just the very single next value in the file is a double. And then I'm saying read 3 more. Are there 3 more? I don't know that for certain. I only know that there's 1. I only know for sure that there is 1. Does that make sense? Or the other way to think about this, whenever you read in a value from the file like this, it consumes that value. So if I'm looking at this from the perspective going through the file, the first time I say n.nextDouble, it consumes this one. The next time it consumes this one, and the next time it consumes this one. And then I'm saying, all right, is there another double after that? And it's saying, yes, there is. There is another double after that. This is, in fact, a double, right? But then I'm reading in 3 more values. 1, 2, 3. Okay. Well, let's think about what's going to happen at the very end. Maybe the loop stops right here. Is the next value a double? Yes, it is. But then I say read in 3 more doubles. 1, 2, uh-oh. I'm at the end, right? There weren't 3. There weren't 3 for me to read in. It didn't exist. That's what this error is telling us about. No such element exception. You read in the last value, you tried to read in another one, there wasn't another one. That other value didn't exist. So be very careful. I think it's the lesson here is to make sure that, oops, that's not the right, that's for a different class. Make sure that you understand the structure of the file. Why didn't it fail when I only had 2 here? That's actually a little interesting wrinkle. It's because there's an even number of doubles in the file, so it just kind of happened to work out, right? Just kind of happened to work out that way. But in practice, we don't want to rely on that luck. We don't want to rely on it just happening to work out. You need to make sure that if you read in this value, that it is there. Ask the question first. Is there another value for me to read in? If this answer is yes, then I know I'm safe to read in 1 value, just 1. This only tells me if the next value is a double. Now let's use this to, I think this actually has an exercise involved with it, which is to determine, I can't remember if it's the largest or the smallest value in the file. I'm not sure that it really matters whether we go for the largest or the smallest. They'll be similar either way, but printing these values is not what we want. I only care about, let's do the largest one, just to pick one. We'll go ahead and complete that exercise. Before I look at the values in the file, right, I want to, or let me take a step back. I want to keep track of the largest value that I've seen, right? And then if I see another value that's bigger than that one, I'll just update it and say, okay, now the largest value I've seen is this new one that I've seen. If I see a new value that's smaller than this largest value, then I don't have to do anything. I just be like, all right, that's not bigger. Does that kind of make sense? That's kind of the thought process here. So let's see if we can work out how to do that. I'm going to need a value to keep track of, you know, the largest. What should I start this at? 0? What if all the values in the file are negative? That doesn't work then, right? I'm sorry? Negative infinity. So there is a way to say negative infinity, and I think that would work. I actually don't remember how to do. I'd have to look it up. How to write negative infinity. I'm pretty sure there's a way to do it. I have another way in mind though. Let's assume that the largest value that I have seen so far is the first value in the file. Right? I'm at the very beginning. The largest value I've seen so far is the first. It's the only value I've seen. It's the first one. Let me take a step back and show you something else real quick that I kind of skipped over. In is my scanner. We all know how to use the scanner to say n.nextInt, or in this case n.nextDouble. Watch what happens when I hit the dot though. Eclipse pops open this little window, and it's trying to help me out here. It's saying here are the things that are available for you to do with this scanner. You'll see nextInt is on here, nextDouble is on here, some of the other ones that we've used are on here, and if I click on one, it actually shows me the documentation, right? What is this documentation? It is quite literally the same thing. If I can find the proper, Control F failed me this time. All right. The documentation for next int says scan the next token of the input as an int. And if I look at the documentation for next int here, right? Click on it, it says scans the next token of the input as an int. This is quite literally ripping the documentation directly from the website. It's the same thing. It's the same thing. Eclipse is providing all of this information to you directly. And honestly, I don't care where you get it from. If you Google it and you find it on here, or if you're able to get it through what Eclipse provides to you, great. Awesome. Either approach is okay. But I'm trying to build that confidence in, reading about something new that maybe you haven't seen or used before, and then having the confidence to try it and use it in your code. That's programming. That's a lot of what programming is. Sort of taking the leap of faith that this is going to do what I need it to do, and I'm just going to trust that. I don't know how it works, but they're telling me it's going to do this, so I'm going to use it, and I'm going to trust that it's going to do that, like it's explained to me now. So if we return to the problem at hand, our largest value is just going to be the first one, and then while I have more values in the file to look at, we can, create a variable for our next value, read in the double. If the next value is greater than our largest value, then our largest value is the next value, right? So we'll update the variable accordingly. And then if we want to, down here, we can print out the largest value. This pattern, very common, very classic pattern to use. Also, I hope you could see how you could use this to find the smallest value in the list. Instead, you literally just have to flip the sign. And now this finds the smallest value in the file instead of the largest value. Let me run the code here and show you that it does in fact run hopefully properly. Let's see. All right, it's telling me that this is the largest value, and I don't actually know if that's true or not. I'm pretty sure it is just because of the code. The code seems reasonable, but I'm not going to go through all 1,000 of those. If you want to go through all 1,000 and check, by all means. I'm going to trust that the code is doing what it's supposed to be doing. But before I move on to the next exercise, I want to show one other situation where I feel like people might run into trouble. Some people may have wondered why I did this. Why did I make this variable? Couldn't I have just done something like this? Okay, so that's not going to work. But, well, maybe if I do this, right? Yeah. It would. It consumes it. It consumes it. I cannot use in.nextDouble to read the same value twice unless it appears in the file twice in a row. Right? That would be the way to do that, right? Or another way to think about it, if I'm looking at this, right? The first, this one is going to read the very first value out of the file and say that this is the largest value I've seen. That's actually a very small number, right? E to the negative 4, so that's a very small number. This call to in.nextDouble, this usage of in.nextDouble, is going to consume the next value in the file. So it's going to look at this one, and it's going to say, is this value bigger than the largest? Well, yeah, it is, right? It is. But then this one is going to read the next value from the file, right? Because the prior value was consumed. So I'm not going to set the largest value properly. This is the one that I compared to in the if statement, but this is the one that would get stored as the largest value, and that's not correct, right? That is not correct. So I was aware of that when I started writing this, and that is the entire reason why I created this variable, because I knew that if I used in.nextDouble in multiple places, it would proceed farther than I wanted to go. Again, be very careful. If I say that there is one double here, I know that there's just one. So please only do this one time. There are exceptions to that rule. In fact, you might run into some exceptions to that rule on the assignment. But if you ever need to reuse a value over and over again, create a variable. That's kind of the short and sweet story. That's what variables are for me to be able to reuse values over and over again. Any questions about this before we move on to a different direction? Yeah.
Just what exactly is the file called?
This file is called 1kdoubles.txt.
Okay, so you never have to actually name the file itself.
That's what this code is doing for us up here. When I run this, the first thing that happens is it pops up the box, and then I'm saying which file do you want to find, do you want to use with this program, and I'm selecting this one. Okay. I could select this one, and I think it would still work. I mean, it's not doubles, but I think integers can still be read in as doubles, so I think, why is it doing that? Yeah. So yeah, it still works. It tells me that 332 is the largest value in that file. Yep.
And if you include that code before, it will prompt you to.
Correct. In fact, you will see this as part of your assignment 4 when you start it. Yep. But you don't, again, I'm not going to test you on this stuff. I'm not expecting you to understand this stuff other than it's what loads up the files. Like, that's literally all I'm expecting you to know about this code. Any other questions before we move on to the next example? Okay, so yeah, input comes in other forms as well. So one thing that we like to, we've been using keyboard input in the sense of, type things in with scanner, right? But that's not the right kind of keyboard input that we need if we were gonna do, if we wanted like instantaneous feedback. So like if I'm playing a video game, right? And I wanna, move in a direction. I push the button and I move right away. I don't have to like hit the enter key afterwards, right? It's just automatic, right? So scanner is not for that purpose. Scanner is for, kind of the quote unquote slow text input or slow keyboard input. For the kind of keyboard input that I was describing, the more instantaneous feedback, we actually need a different set of tools. And the nice thing is that the set of tools we're going to use also allows us to access the mouse. So I'll show you how we can track mouse input as well as drawing stuff. So we're going to be drawing images and shapes and animations even on the screen with the next stuff that we're about to look at. But let's start with the keyboard and the mouse first. The API that I'm showing you is called Standard Draw. So STD stands for standard. That's a very common computer science abbreviation. You'll see it all over the place. It uses just an abbreviation. Standard Draw is a library that is provided by Princeton, actually, who did a very popular Java textbook a while back. We don't use the textbook anymore, but we do still use their wonderful Standard Draw library. So this is not an official Java library. This is one provided by the University of Princeton, or Princeton University rather. But the same points still remain. You'll notice that they even, kind of have a similar looking documentation page to the one that we were just looking at. And so Standard Draw is what we're going to use to do keyboard input and mouse input and drawing shapes and all that other kinds of stuff. And there's actually other things you can do with it that I'm not even going to show you. You can use it to play sounds and music and things like that. That's all in here. So if you're interested, you can take a look at the documentation and see how far you can take it. But we're talking about keyboard input. And so I just did a Control F for keyboard, and I see that it's leading me to a few different methods. Those look like they're for the mouse, but these look like they're good for keyboard. It's saying has next key typed. So it's kind of similar to what we were looking at with the scanner. Next key typed. If I click on one of these, you'll see it takes me to documentation. Returns true if the user has typed a key. And then this one is going to give us the key that was typed by the user. Notice that it's a similar kind of thing that we just saw. Once I ask it to tell me the next key, it consumes that, right? So when I say next key the next time, it'll be whatever the key they pressed after that. It'll never give me the same key twice in a row. Let's take a look at how we can use that in practice. this loop right here. The way that I would say this in English is, so we just saw the documentation that said this will return true if they've pushed a key on the keyboard. There's a not sign out in front of it though, right? So that makes everything opposite. So in English, I would say, while they have not pressed a key, that's how I would interpret this. While a key has not been pressed, we're going to wait. Standard draw.pause does exactly what it sounds like. These units are in milliseconds. Computers are very fast, right? So these units are in milliseconds, so this is about 1/10 of a second that we're waiting. So think about what this loop is doing. It is literally sitting there, and the name I would use for this, it's spinning. Every 1/10 of a second it's saying, did you press a key? 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 As soon as I decide to push a key, this will be true, right? The not will make it false, and this loop will be over. So this loop is literally going to sit there and wait for me to push a key. I will not exit this loop until I hit a key on the keyboard. Once that's done, we're going to look at the key that was pressed and decide what to do. Here's a new data type for you today, although it's similar to a data type that we've already seen. Very controversial how to pronounce this particular word. It's short for character, so the correct way to pronounce it is care. And if you pronounce it char, I'm just kidding. I actually do strongly believe that the correct way to pronounce it is care, as in character, not char as in Charizard, because you know, we're doing computer science, not Pokemon. But it's a hot debate, one that we don't necessarily need to get into right now. Regardless of how you say it, it does represent a single letter, a single character. So strings, that's lots of letters, right? What is it a string of? It's a string of characters, where we literally mean characters, right? Characters. Notice the single quotes. Strings use double quotes. Single characters use single quotes. That's another thing that can kind of trip people up. But regardless, here is our next key type method. This is going to give me the actual key that I push. And then I'm going to ask, did I push a Y? If I did, I'll say yes. Did I push an N? If I did, I'll say no. If I push any other key, it's just going to be like, huh? I don't know what you're talking about. It's a very simple example. Let me try to run it for you and show you. Okay, so this window is something that Standard Draw is going to pop up. It's used for drawing stuff. We're not drawing stuff here, so we're just going to ignore it for now. We'll get to drawing stuff a little bit later. My program is running, though. It is running. It doesn't look like anything's happening. Nothing's going to happen until I push a key on the keyboard. So right now it's stuck in this while loop, and it's checking every 1/10 of a second if I push the key on the keyboard or not. So I'm going to go ahead and push one, and I'll push the Y key. Oh, whoops. Hold on a second. Which one did I run? Did I run the wrong No, I'm running the right program. Oh, I'm sorry. The keyboard input is based on the window, so I have to have the window up before I push the key that I want. So now if I push Y, it exited the loop, grabbed the key that I typed with this line, and then ran this if statement to check and see what that value was, and printed out yes. Let me annotate this a little bit. I'm going to come in here and put a print line statement inside this loop just to really illustrate what's happening, and then run this code again. Now it's telling you exactly what it's doing, right? It's waiting. It's waiting in the loop, waiting for me to push any key on this keyboard. How long is it going to have to wait? I don't know. That's why I used the while loop. That's why I used the while loop. Could I have to wait? Could have to wait till the end of time, right? I could just get up and walk away and leave my computer here, right? Could sit here forever. Question? I'm sorry, what if I did what?
If you didn't have the 100 milliseconds in here.
Yeah, great question. You can certainly play around with this number and find out. I mean, obviously, if I go bigger, you asked about smaller, but if I go bigger, you know, that's a second. So you'll see that it's only going to prompt 1 second in between, right? Which means there'll be some delay. I can push the key at the right time, and then there's a delay. That's probably not what I want. So checking more frequently is better, but what happens if we go smaller? And you asked what if I take the number out altogether. We'll try that in a second too. So I can go shorter. The problem with going shorter is computers are very fast, faster than me. And so now I'm pushing keys, but, oh wait, I don't have the window highlighted. Yeah, there we go, it worked. Yeah, it still worked. Let's see what happens. I actually don't know what will happen if I take it out. It won't run. It has to have a number in there. Yeah, not optional. What if I put 0? I think it'll quite literally pause for 0, which is essentially the same as not having this in here at all, right? Why even bother? If I'm going to pause for 0. This is not an exact science, though. I think tweaking that number to kind of get it to be the right delay, the right feel for your program is pretty common. Yeah. We'll see that actually a lot more clearly when we do animations in a little bit. It's going to start to matter a lot more. And so, yeah, that's how keyboards work. And the good news is that, let me try a different letter. So I pushed K this time, right? Letter K. Just have to take my word for it, I guess. Failed all the comparisons and said, huh? I don't know what you're talking about. And the interesting thing here is that the mouse works kind of a similar way. So if I take a look at the mouse demo, one thing to note here, you might see this if you look at this. I actually just noticed this before class, and I wanted to change it real bad, but I figured people might have already. Anyway, this needs to be updated. You can see it's crossed out. The official word that it says is that it's deprecated, which is actually an English word. It means that we don't want people to use it anymore. The reason being is they changed the name. It used to be called mouse pressed. They changed the name of it. It's called is mouse pressed now. So that's the one that I should have used. They do the same thing. They do the same thing. But that's a warning that basically says this is going to go away sometime, so you better start using the new one, because as soon as the old one goes away, this is not going to work anymore. So just a little aside there. The questions for the methods that Standard Draw provides for operating the mouse, you can see we've got get me the X position of the mouse, the Y position of the mouse, and then whether the mouse button is pressed. That's going to be the left mouse button, I believe, by default. I'm pretty sure there's a way to get the other mouse buttons, but again, I don't remember off the top of my head. Would have to read the documentation. Notice though, again, I've got all this done in a loop, and I'm polling this time every second. Just so that we can see clearly what's going to happen. I'll fire this one up and show you that the X and Y coordinates are based on this window, based on this screen. So if I hold the mouse outside of the screen, which it currently is, it doesn't really know how to deal with that. But as soon as I bring it inside the screen, inside this window, we can start to see those coordinates changing over time. And we can see the coordinate system appears to be, similar to what we would expect. As I get down to the lower left corner, it gets very, very, very close to 0. As I get to the upper right-hand corner, it looks like it's going from 0, 0 to 1, 1. So it's just a unit, unit square for our coordinate system. Yeah. You can, yeah, you can change the size of the window, but you have to do it in code, I believe, to make it bigger. I don't think you can do it the way that you're probably used to by grabbing the corner and dragging it out. But I'm pretty sure there is a way to make. You can also change. There's lots of things you can change. So I'm glad you asked that question. The coordinate system is set to go, from 0 to 1 on both the X and the Y axis. But if you don't like that, you can change it. You can make the X and Y axis go from whatever coordinates you want. So if your problem fits more nicely in a different coordinate system, then you can change it, right? That's a convenient thing to be able to do. For a lot of what we need, though, this is fine. Using values between 0 and 1 is not going to be a problem for us. As far as whether the mouse button is pressed or not, there is a little bit of nuance there. It's whether it's currently down, right? So whether the mouse button is currently down, I'm holding the mouse button down now, and you can see that the mouse button is saying that it's pressed. But as soon as I let go, mouse pressed is false. I'm not holding the button down any longer. And so then think about what makes a mouse click. That's kind of the other thing that I wanted to go through with you. This exercise here deals with the mouse and a keyboard thing. It also has some drawing. I'm going to skip the drawing part for now. I'm going to go ahead and take that out and just focus on the mouse part. We'll get to drawing in just a second. But if I want to wait for the mouse to be pressed and released, right? Wait for the mouse to be pressed and released. Those are two different actions, actually. So with the key, I just push it and it's done. With the mouse, I have to push it and let it go. That's what constitutes a mouse click, right? The click doesn't register until you push it and let it go. That is, in fact, a mouse click. So we have to wait for both. And I know it seems a little silly, but I could push that button down and hold it down for as long as I want, right? I can also sit here at the beginning and not push anything for as long as I want. So when dealing with the mouse, again, while loops. Whoops. It's going to look similar to the one I did for the keyboard. Standard draw. While the mouse is not pressed. The problem doesn't ask for this, but I'm going to put this in just for our own understanding. Right? And then I probably need a pause. I can try it without the pause. I think what I'm worried about if I do it without the pause is that it's just going too fast for it to pick up. See how fast it's going now compared to with the pause? Oh, it worked. It worked. Even without the pause. Interesting. I still think it's a good idea to put the pause in because pausing is also just sort of a kind, considerate thing to do. Consider that this is not the only program running on your computer. So pausing gives the computer a chance to do some other things that are also running on your computer, right? So that you're not just hogging everything for this program. So here the mouse has been pressed, and I'm actually, you notice I just copied the loop. I'm going to take the exclamation point off and then change this message, waiting for mouse release. Now it's waiting for the mouse press, waiting for the mouse press. I click and hold the mouse. It's now waiting for the mouse release, waiting for the mouse release. And then I let go, and that's a mouse click, right? The press and the release, that is a click of the mouse. Normally we don't draw it out for so long, right? I just go boop, but that works too, you know? That works as well. The normal click or delayed, drawn out click, both of them, this code will accommodate. Okay. There's how to draw some text on the screen. That's a pretty easy thing to do, but any questions before we move on to drawing? That's our last stop for the day, is drawing some stuff on the screen. It's also really fun. Any questions? Yeah, in the back. Absolutely, yeah. All right, let's talk about drawing stuff. It's kind of our last big topic for today. We're going to start by drawing just static shapes, shapes that don't move, that we're just drawing pictures, right? But I want to talk to you about animation as well, because that's a really fun thing to be able to do. And so we can change colors. I actually want to talk to you about a few different ways we can change colors. There are some colors that are built in. In fact, if I type color dot, you can see here's a list of all the colors that are just kind of built in, the generic ones. But there's actually a lot more colors than this that exist in the world. We can create any color we want, similar to this. But in order to understand how this works, take a look at these three values. The first one represents the amount of red that's going to be included in this color, where 0 is no red and 255 is all of the red. And then the second value is how much green is in the color. And then the third value is how much blue is in the color. So this is saying all of the red, and it's 0 to 255. That's maybe half of the blue, like on the scale, right? So it should be in the purple range for this color. So the first shape's going to be green. The next shape is going to be kind of purpley. Maybe we can change the colors a little bit. And then you can see this is how we draw the actual shapes. But what do those numbers represent? You can maybe kind of reason through it by running the program and looking at what it actually produces, right? I see my squares appearing right dead center. So 0.5, 0.5, yeah, that sounds kind of like dead center, right? The 0.2 then, well, I mean, we don't have to guess. That's kind of the point I'm trying to make. We don't have to guess. Filled square, here it is. Double X, double Y, draws a filled square of the specified size centered at XY. All right, so X and Y are the center. That's the center. And then this is the half length or the radius, which I know is a weird term to describe. But that's, it's a square, not a circle. But it's the radius of the square, right? Again, you can kind of verify that just by tweaking these numbers a little bit. If I make this 0.1 instead of 0.2, then the next time I run this, the square is going to be smaller, right? Significantly smaller. Here's my purpley. I don't know if that's purple or I feel like that might be more pink than purple. If we wanted to make it more purple, though, we could jack this up. More blue should maybe make. I'm not an art person, so I don't know if that's correct or not, but let's try it out. Oh, that made it more pink, in my opinion. I'm not sure. Made it a lot more pink. Is it? I don't know. It's some kind of purple, I guess. We could also just compare it to the default purple. Oh, they don't give us a purple. How dare you? Pink. Magenta is kind of purple, right? But it's not purple. It's not the same. Anyway, the other thing too is you don't necessarily have to guess with these values, right? A lot of people would just use a color picker. So a color picker is a nice way. Here's RGB right here, right? So if I want, a nice deep purple, looks like it needs to have some green in it and less red. So less red, more blue. Yeah? Try these RGB values. Oops. I got distracted when I was messing with the code. Oh yeah, that's purple. Yeah, that's purple. Cool. Cool, right? So it's pretty fun stuff. And then there's some other examples down here. I don't know that I'll have time to do these necessarily. They're also pretty straightforward. They're not tricky, Some of them do get a little tricky, such as this one. Draw an unfilled red triangle somewhere. So you might say, all right, I see there's methods for squares. There's methods for circles. Certainly there has to be one for a triangle, right? Triangle does not appear anywhere in this document. No triangles. Does that mean I can't draw a triangle? No, there's still a way to do it. But we just have to take a different route. So let's see if we can figure out some more information about where is it drawing those shapes. Let's take a list of what's available to us. So I see, polygon. There we go. Polygon? That can be anything. Polygon can have any number of sides. What is it expecting? An array of x values and an array of y values. We have a term for this. We're going to start seeing these pop up a lot more often. These are parallel arrays because the first value in the x array and the first value in the y array go together to make an xy coordinate. So if I wanted a triangle, I would need two arrays. Each of them would have 3 values, right? One for each of the 3 corners of my triangle. Fill them with the x and y coordinates where I want the triangle to go. Let's do that one real quick and then we'll move on to the next one. X equals 0.1, x values, 0.5, 0.9. I'm going to make a big triangle. double y is equal to 0.1, 0.9, 0.1. I think that'll work. Let's see. And then we would say standard draw dot filled polygon with my x and y arrays. It's telling us it's expecting two arrays, one with x, or actually I should click on this and show you, right? Draws a filled polygon with the vertices x0, y0, x1, y1, all the way up. Did it work? Let's see. Oh yeah, it worked. There's my triangle. It's covering up my square. It's covering up my square. It does it in the order that I do it, right? The computer's not going to stop me. So if I don't like that, I got to go fix the order. I got to make the square bigger or move the square somewhere else. Yeah. How do you make it unfilled? Yeah, let's take a look. So for all of these, there's a filled polygon, filled circle, filled square, but I think if you look around, you'll also see there's one that's just called polygon. And there are also ones that are, so like just circle, just square, just rectangle, those will just be the outlines. They won't be filled in. So yeah, if we want it to be unfilled, that would stop covering up the square, huh, if I did it that way? Take that out. Oh, lowercase p. There we go. Cool. Looks pretty good. I mean, I don't know. Looks kind of Illuminati-ish, but getting there. All right. Any questions on that before we switch to our final, but also, in my opinion, coolest topic of the day, which is animation. Animation is fun stuff. People like animations, like obviously we like watching cartoons and things like that. Video games also follow the same process. Animations, for those of you who aren't familiar, or movies, or video games, it's a series of pictures drawn one after another. It's a series of two-dimensional images drawn one after another. The trick is that you draw them very quickly. So if you draw them fast enough, it fools your brain into thinking that it's not just a series of images, but it's actually motion. It's actually stuff that's moving. So those images are called a frame. One image is called a frame. That's true for both movies and video games. If you're a gamer, you've probably heard of frames per second being how many times I can draw one of those things on the screen, right? We're typically aiming for at least 30, but the people who really care about video quality will say 60 is what you need, right? In this class, I don't really care as long as it looks reasonable. I'm not going to nitpick about how many frames per second you're drawing. I just want it to look pretty good. But what I would like to go through with you is how to set up these animations, because it is somewhat complicated, but the good news is that there are some similar parts, some similar moving parts that you can use in all of the animations that you want to make. So first off, notice there's a while true loop. This means that whatever animation I create is just going to run forever, or until I stop the program, right? But this is important. There has to be some kind of repetition. Remember, I am drawing a lot of frames very quickly, one after the other. That's repetition. So there's a while loop. Step one of doing animation is clear the canvas. Delete the last frame, right? We show the frame on the screen for a fraction of a second, and then we erase it and get ready to draw the next one. That's what we're doing here. So erase the old frame, start with a blank canvas. Step two, which I would say is actually all of this. This is step two. That's draw the objects on the screen. But drawing the objects on the screen can be very complicated. If I have stuff that's moving, that means I have to update the position of that moving thing first. So we'll talk more about that in detail in just a little bit. And then we actually have to draw it. So here I'm using standard draw.point, which will just make a little circle on the screen. And then finally, this last bit which again, you can see I need to update this as well. I think I could, yeah. This is similar to pause. In fact, I think you could probably just use pause here instead. We'll find out in a moment when I try. This dictates how fast I'm drawing the frames, right? So 10 milliseconds is actually very quick. That means I'd be drawing 100 frames per second. That's a lot of frames. It's a lot of frames. For simple animations, though, very doable. If you're trying to do complex animations like 3D first-person shooter, that's going to require some more work. You probably aren't going to be able to crank out that many frames unless you got a really good graphics card or souped-up computer, something like that. Again, I'm not too concerned about it. I'm concerned about smooth animation. So let's run this, and I'll show you what happens. Smooth-ish. There's my ball traveling across the screen. I actually think it's flickering in part because this number is so small. I wonder if we make it a little bigger, if it'll run a little bit more smoothly and not flicker so much. Okay, yeah, it worked. But it's also moving slower. That should make sense, right? I'm waiting longer to redraw. So it's moving slower, but also more smoothly. Let's take a step back and take a look at this section of code. I skipped over it before, but now I want to take a look at it and try and understand what it's doing. I've got this variable called ball x that represents the x position of the ball, right? Every frame, I'm saying update the position of the ball to be 0.005 farther than it was before. So that's going to make it move to the right, correct? Make it move backwards to the right, or make it move to the right. And then if it gets all the way to the side of the screen, if the x position of the ball is greater than 1, that means that it's gotten all the way over here on the right-hand side of the screen. So we reset it back to be the left-hand side. If you want to, though, you can see what will happen if we don't do that part. It could be a fun little thing. Oh, let me make this faster because that's like a turtle. All right, I'm gonna take a 0 off of there. This is, well, I'll talk about that in a second. I need to stop getting distracted. All right, now it's moving faster, and oh, there it goes. It's over here now. Okay. Now it's outside the building. Going to, I don't know what's out there, right? The point I'm trying to make here is that if you want something to stay in the window, that's your responsibility. If you're moving stuff around, making things move, you better make sure that it stays in the window because the computer is not going to do that for you. That's your responsibility. So that's the whole goal of having this code in here, right? If the ball is too far right, move it back to the left. But actually though, let's think about this. Having the ball just magically reappear on the left side of the screen isn't very realistic. I think, something that might be a bit more realistic would be if it bounced and moved back the other way. We can do that. First, let's recognize this value has a name. What would I call that value in like physics class? Speed or velocity, I think is the physics term. That's how far it's moving, right? How fast the ball is moving. So let's call it that. I think instead of having this number here like this, let's call it what it is. It's a velocity. Actually, if we wanted to be especially specific, right? The ball has multiple velocities. This is the x-axis velocity. It also has a y-axis velocity, but we're not really messing with the y-axis right now. So, I might go so far as to say ball x velocity. And I'll just set it to be whatever value it was, 0.005. Okay? That allows me to come down here, and instead of using the number, I can use this variable. But what makes things even more interesting, perhaps, is that now inside of this if statement, once I've determined that I hit the right-hand side of the screen, I don't want to move the ball. I want to change the velocity. I want to make it bounce. And I'm not going to worry about friction or any of that weird stuff in this class, right? That's a physics problem, not a computer science problem. We're just going to make it pure elastic, which means that what happens? The velocity is going to go back the other way. So we can say that. Negative ball x. Oops, that's, wow. Okay. Let me put the negative sign out in front. Flip the sign, right? Flip the sign. Let's try it out. Let's see what happens. Bounce. Whoops. Oh, gosh. Now it's all the way over there. This works for the right-hand side, but if we don't want it to go off the left-hand side of the screen, then we need code to handle that too. That's our responsibility. That's our responsibility. The good thing is, or the nice thing is, that because we have this variable, it actually becomes kind of straightforward, right? If the x position of the ball is greater than 1, or the x position of the ball is less than 0, let me update this comment. Then I'm flipping the sign of the velocity, right? If it was positive, it's negative. If it's negative, it's now positive. Can run this. And now hopefully we have a ball that will, remain in bounds. And so if we wanted to, which I do, we can also bring the other axis into play. I'm going to copy these and make a y value for the ball, which I believe it's starting at 0.5, and a y velocity. It doesn't really matter where it starts, I guess. When we update the x position based on the velocity, we'll have to update the y position based on the velocity as well. And I can run it, and you might be able to guess what's going to happen when I do. Hopefully you can. Oh, whoops. I made a mistake. Anybody see what mistake I made? I accidentally forgot a thing right here. When I'm drawing the point, I'm saying the y value is always 0.5, but that's not true anymore. I'm trying to use this variable to represent the position of the ball, trying to change the position of the ball on the y-axis, so I need to replace this. All right, let's try that again. Oh, there it goes, right off the top of the screen. But that's okay, we know how to fix that problem. I'm going to duplicate this logic for the y as well. Should work exactly the same, just for the y-axis, right? Okay, cool, right? It's like watching your DVD player to see if it'll ever hit the corner of the screen. Oh. Oh. Hey, yeah, all right, it did it. Best thing that's happened to me all day. All right. Oh, but wait a second. One ball is cool and all, but why am I limited to that? Couldn't I make a whole bunch of them? What if I wanted to make a whole bunch of them moving around the screen? What would I need to do? How would I keep track of all that stuff? Am I going to make a bunch of these variables? I could, right? I could duplicate these variables and then duplicate all the... What might be a better way? I'm sorry? Index to an array. An array. Yeah. Using an array. Yep. Our good friends arrays that everybody knows and loves really well. All right. Good time to practice some more. So instead of having the x positions and the velocities just hanging out as generic variables, what I want is an array to contain those things. There's 4 values that I'm keeping track of for each ball. X position, Y position, X velocity, Y velocity, right? So I could have two arrays, one for the positions, one for the velocity. I could have one array that just does all four if you wanted to. I'm not sure that I really care too much either way. But they're both two-dimensional, I would argue, if I want to have multiple balls, correct? So let me show you what I mean by that. If I make one array for the positions, then I have to decide on, well, let me first decide on how many balls I want. We'll start with a very modest 10. And we'll make this have 10 rows, so one row per ball, and then two columns, right? One column represents the X value, that will be column 0, and one column represents the Y value, that represents column, or that will be column 1. And then I'll make another one for the velocities. Just forget how to type all of a sudden. I shouldn't use 10 here, though. I should use number of balls, shouldn't I? There we go. What's going to be in these arrays after I create them? Zeros. That's probably not what I want. I probably want to initialize these positions and velocities to be something. But we can do that. We can write a little loop to do that. I is less than the number of balls, I plus plus. And then for each one of these, I will just randomly generate a value, right? So for positions I 0 equals math.random. This actually works pretty well for the positions, right? Because the x is from 0 to 1, the axis is from 0 to 1, and math.random is also from 0 to 1. So this works pretty well. Let me put a comment here. Initial x for ball I, right? So the 0 column represents my x coordinate, the 1 column represents my y coordinate. And then we'll do something similar for the velocities. The 0 is going to represent my x velocity. These we want to be tempered a bit. We want them to be a bit smaller. So I'm going to multiply by a fraction. I don't know if that's a good number or not. It might take a little bit of trial and error for me to figure out what that should be. So this will be my initial x velocity. And now, I don't need these anymore. I'm going to pull them from the arrays now, right? So after I delete those variables, all of these things go red, but that's kind of a good thing. Now I know what I need to fix. Any of these values that are underlined in red, those are values that I now need to reference my arrays for. So the ball x position, I know how to get that, but first I need to recognize the fact that there's going to be multiple balls to be done. So I need another loop here to update the position of all of them, right? And do that stuff. So it's going to look just like the loop that I wrote up above. Let me fix my indentation. So anywhere that I say ball x, I have to remember, all right, the x position of the ball is actually here. Everybody with me? Anywhere that was ball x, that's now coming from the array. So I can actually just go through and replace. There's actually a faster way to do this, but this code isn't very long, so this will work okay. Anywhere that I have ball x velocity, that's this, right? That represents the x velocity of the ball. So anywhere I have ball x velocity, I can just replace that with that array reference. And then it'll be a similar story for the ball Y position and Y velocity. Just replace these variables with the array references. And then we'll be able to take a peek, see if this code actually does something cool or not. I hope it does something cool. Oh, I still have 2 more down here that I need to fix that I didn't see. And actually, I need to be a little careful. Right now, this was outside of the loop, so that would have been a mistake to leave this outside of the loop. That should be inside of the loop. I need to draw every ball. And actually, you can see that I can't even refer to I outside of the loop, which kind of makes sense, right? I is my loop variable, so this statement doesn't make sense unless it's inside that loop. Let's try this again now. And okay. They're working, they're bouncing. The animation's a little choppy, which I would attribute to, you know, could be the speed. I think there's definitely some room for playing around with the pause values to see what might make it a little bit more smooth. I don't like that it's flashing so much, to be honest with you, but the motion of the balls is working. And what's, let's see, what if I change this to filled circle, I wonder? Instead of point, would that help? Oh, that's going to be really big. Well, I made them smaller, but they still do effectively the same thing. They're still flashing a little bit, and that's okay, I guess. It does bother me a little bit, but not enough that I'm going to sit here and mess around with it too long. What's nice about this, though, the way that I wrote the code, right? If I come up here and I say, all right, I want 100 of these things, then the code will happily oblige. Oh, see, here's the problem now, though. It can't keep up. It's taking too long. It's taking too long to draw everything. You can actually see how long it's taking to draw. We have to slow it down even more. What am I feel like I'm missing something here. That's kind of trippy, but not what I'm going for. What if I switch this back to show? I wonder if that'll fix it. Oh yeah, actually that worked pretty well. That's a lot cleaner than using pause. I'm gonna have to look into that and see why that is. But yeah, it's working great. Or 1,000 of these, why not, right? Oh boy. Oh my goodness. There they go. Looks like static on my TV. Anyway, there's lots of cool stuff you could do with this. I could make the balls different colors. I could make them change colors based on what position they're in on the screen, right? All kinds of cool, fun stuff. I know that dragging arrays into this made this significantly more complicated. If the array stuff, if I lost you on the array stuff, don't freak out too much. The big picture that I want you to take away from this is that the animation process follows the same 3 steps. Clear the canvas, update the position of anything, and then draw it, and then call show or pause to wait, give the frame time to display on the screen. All right, everybody, we're going to wrap it up for today. Let me know if you have any questions. Otherwise, I'll see you in the labs later this week.